Alright, so let's take a look at this experiment, which has two light bulbs and one battery. The electricity runs from the battery to the first light bulb, goes through there, then on to the next light bulb. Okay, because it goes through one to the next, we call this situation series. If things are lined up so that you have to run through one to get to the next one, it's series. Now, in this situation, you might expect the first one to be brighter because it gets the full current and the second one would be dimmer. But when we do this, if they're identical bulbs, they're exactly the same brightness. And what that tells us is that current is not used up. Okay? Current is the same throughout the entire circuit. Now that's important. Remember we said that charge is conserved, and current is just how much charge flows through in a given amount of time. So if I had 3 amps coming in here on that side, and I only had 2 amps leaving, then I would be leaving 1 coulomb every second inside here. That would be a huge amount and would cause serious problems if we were actually dumping 1 coulomb per second inside this light bulb. So no, that doesn't happen. If I have 3 amps coming in the first one, I'll get 3 amps going out the second one. Alright, so in a series situation, everything gets the same amount of current. Alright, so that's this situation here. We call this series. Now in this situation, the current comes out here, flows into this junction, but now it has a choice. It can either flow through this light bulb or through this light bulb. Alright. In that case, there's no requirement that the current in the left light bulb match the current in the right light bulb. Okay. What is required is that when the current comes in here, the total amount that goes left plus the amount that goes right has to equal the amount that came in. Alright, so if this is I, and the current flows in and goes out at the junction, then the total current flowing in has got to equal the amount that goes out through the top, I1, plus the amount that goes out through the bottom, I2. The other thing that's true over here is that the energy per unit charge, or the voltage drop, from the beginning to the end has to be the same for both of these. Okay. This one can't drop by 2 volts, 2 joules per coulomb, when this one only drops by 1 volt, 1 joule per coulomb. We call this setup where they can split their current however they like, but they have to have the same voltage drop. We call that parallel. All right. Now I like to describe these in terms of water flowing or in terms of water slides. Okay, so let's suppose we have a nice ramp, or a ladder. Let's make it a ladder. And at the top of that ladder, we've got different water slides. So this one comes down in kind of a wiggly fashion to a platform, and then another wiggly slide down to the bottom. And the other water slide just has a big drop straight down to the bottom. Now, a couple of things we know. First off, whatever people come down this first water slide, if he goes down the first water slide, he's going to have to go down this one. Okay? There's no option to go down this one then jump off. That would be very bad. Second, there's no reason why we have to have the same number of people choose this water slide as choose this water slide. But all the people that walk up the ladder have to come down one water slide or the other. Okay, that's current. Every person that goes up has to come down. And then in terms of voltage, remember voltage is like height, energy per unit charge. Whatever energy we add in going up had better match the energy we lose coming down, whether we come down these two or come down this one. Okay, so if I have 5 people go up, if 5 people go up and 2 people come down this way, then I'd better have 3 come down that way, otherwise I'm in trouble. Similarly, if this ladder goes up 3 meters, and this is a 2-meter drop, then this one better be a 1-meter drop, and this slide here had better be a 3-meter drop. Okay, so these two sets of slides are in parallel, these two here are in series. Series if you have to go through one to get to the next, parallel if you have a choice. In series, the current going in one matches the current going through the other. In parallel, the voltage drop across one path matches the voltage drop across the other path. The total current coming into the junction equals the total of the current going through each of the paths going out.